Let us look at proposition number 16 of works of Archimedes, specifically from on conoids and spheroids. This proposition has three parts, so let's take it one by one. The first part says, if a plane touch any of the spheroidal figures without cutting it, it will touch at one point only. And the plane through the point of contact and the axis will be at right angles to the tangent plane. Now, as we have seen in the previous proposition, the same statement with respect to conoids, we have already proved that. So here also it is the same process of proving the proposition. So I'm not going to repeat it. Now the second part says if any conoid or spheroid. So here conoid is also applicable here, but I'm going to show it with respect to spheroid. So if any conoid or spheroid be cut by a plane through the axis, and if through the tangent to the resulting conic, a plane be erected at right angles to the plane of section, the plane so erected will touch the conoid or spheroid in the same point as that in which the line touches the conic. That is a tangent line. So let's see how we can prove this. Cut the spheroid by a plane through the axis. The intersection between the cutting plane and the spheroid will be a conic. So this is the cutting plane passing through the axis. Now the intersection between these two would be a conic. Now take a point P on the conic and draw a tangent to the conic at P. So let's take a point P and let's draw a tangent at P. Next, construct a plane through the tangent to the conic perpendicular to the plane of the conic. So through this tangent line, we have to draw a plane which is perpendicular to the plane of the conic. So let's do that. What this proposition is saying is that the spheroid will also touch this tangent plane at the point at which this conic is touching the tangent plane. So let's assume the opposite. Let's say there is another point N which also touches the tangent plane, and this N is there on the conic, and this conic is nothing but the intersection between the spheroid and the cutting plane. So that means N is on the cutting plane. The perpendicular from N on the cutting plane would be also perpendicular to the tangent to the conic. So let's draw that. N falls outside the tangent plane. Since it is perpendicular to the tangent line, that means it falls outside the tangent plane, which is not possible since the point N should fall in the tangent plane because it is supposed to be the point of contact. Yes. So by proof of contradiction, we have proved that if any conoid or spheroid be cut by a plane through the axis, and if through the tangent to the resulting conic, a plane be erected at right angles to the plane of section, the plane so erected will touch the conoid or spheroid in the same point as that in which the line touches the conic. So here, it doesn't matter where I take this N. It will always be perpendicular to the tangent line, except at P, where it will lie on the tangent line, in turn lying on the tangent plane. So that means that only at P, the plane that is erected perpendicular to the cutting plane will touch the tangent plane. So that was the second part. Now let's look at the third part. It says, if two parallel planes touch any of the spheroidal figures, the line joining the points of contact will pass through the center of the spheroid. So we have a spheroid with center O. So let me mark O. Take two planes parallel to each other and each touching the spheroid at the points P and P prime. So let's draw the second plane parallel to the existing plane and let it touch the spheroid at P prime. Draw a plane perpendicular to the tangent plane passing through P, which we have already done previously. Now, there are two cases. Case 1, when the planes are perpendicular to the axis. These two parallel planes, if they are perpendicular to the axis, that means P has been chosen in such a way that, it lies on the axis. So there it is very clear. The line joining the points of contact P prime will pass through the center of the spheroid. Since both P and P prime are on the axis, and the axis passes through the center. Pretty straightforward, this part, this case. Now let's look at the second case. The planes are not perpendicular to the axis. So let's bring it back. You can put it anywhere. Now the plane passing through P prime and the axis is perpendicular to the tangent plane at P prime. So if we draw, remember this green cutting plane is passing through P. So let's assume that we have drawn another plane passing through P prime and the axis. Then that plane would also be perpendicular to the tangent plane passing through P prime. Since tangent plane at P prime is parallel to the tangent plane at P. Now, the plane passing through P prime and the axis and the one passing through P and the axis are the same. Now, the intersection between the plane passing through P and P prime and the axis is a conic. So that is already shown here. Now, the line segment PP prime passes through the center of the conic. Why? Because the tangent plane at P prime is perpendicular to OP prime. Similarly, the tangent plane is perpendicular to the cutting plane because this tangent is perpendicular to OP. So with respect to the conic, OP prime and OP lie on the same straight line. So which means the line segment PP prime passes through the center of the spheroid since center of the conic and the spheroid are the same. So that is proposition number 16 of works of Archimedes, specifically from on conoids and spheroids. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now. Bye.